Okay, this video is about GCSE topic on frequency polygons and cumulative frequency. These are two particular ways of presenting data. So let's have a look at this problem. A student measures the height, h centimeters of each of 400 plants, and the cumulative frequency diagram shows the results. Well, now this particular problem doesn't actually show us how we got to this frequency diagram. So I've tracked back a little bit and I've created these numbers. So let's suppose that these are the numbers that have given rise to this cumulative frequency diagram. Now, what this is saying is we've taken our 400 plants and we've measured them, and then we've sort of grouped them. So 0 to 20 centimeters, well, we've got 120 of those, and so on. 20 to 30 centimeters, we've got 80 of those, and so on and so forth. So if we add all those up, that will come to 400. Now, we can sort of assume that the original data is is lost to us. You know, all we're working on is this summary of the data, which has basically listed the frequencies by the class intervals. So these are the class intervals here. And now we're going to use this data in order to draw this cumulative frequency diagram. The cumulative frequency diagram is quite a useful diagram because it gives us a pictorial representation of the sort of the spread of the data. There's what we call the central tendency of the data, you know, around, you know, where's the sort of middle of it, and so on. Okay, so the original problem just had this black line coming up here. We often find these sort of S-shape kind of things, but a slightly skewed S, but they're very often that sort of shape. So what have we done? Well, let's have a look. So basically what we've drawn a kind of block diagram, but we've done it on a cumulative basis. So if we look at this first class interval here for 0 to 20, we've got 120. Okay, so that's what this block here represents. Quite a lot of lines on this diagram, but you just concentrate on the red ones for the moment. So that's what that block will represent there. Okay, 0 to 20, frequency of 120. Now, if we were to, we said 20 to 30 is going to be 80, but if we think cumulatively, so 0 to 30 would be the sum of these two. So that'd be 200. And that's what this block, this rectangle here represents. And there we go. And then same again, if we look at 0 to 40, then we've got 120 plus 80 plus 120. So that's what this would be, this 320 here. Now, judging by the graph there, it kind of, that would, if we choose 40 to 60 or 0 to 60, let's say, that would give us 361 as a cumulative. So the number's slightly odd, but I've just tried to reflect it accurately because that helps. So that is that block. And then, of course, the whole lot, that's 400 plants. It is a 0 to 80. So in this whole area, 0 to 80, this is the block that represents that. So we've got these 5 blocks, but of course they are, say, cumulative. Now, that's okay, but you know, in actual usefulness, the usefulness of this actually comes if you can actually represent this with a line. So what we do, if we take the corners, the right-hand corners of each of these, and then connect them up, just put straight lines if we want, but it's equally sort of normal, if you like, to actually try and kind of draw a curve that, you know, sort of goes through them, looks a bit more natural, I suppose. Okay, so this curve here, we can see this one has been curved, represents our cumulative frequency diagram. Now, the thing about this is we can use this in order to draw conclusions about the data. And one of the things we might be interested in is what is the median. That's this part one. Now, if we think back to the data, if we've got 400 heights, we put them all in order, going from the smallest up to the highest, then the median is the middle one. Obviously, slightly, if we've got an even number, then that's, you know, that becomes slightly arguable. But when we've got a large number, we would just kind of go for the 200th, really. So let's have a look at this. So we can actually look at this. This is what our graph is saying. 200, we can read that down to 30. This actually corresponds to one of our blocks, but that's purely coincidence on this particular set of numbers. So we would say that the median for this data, looking at the 200, so the median is 200 out of 400, isn't it? It's halfway. So that's the 200th in our list of plants. And we would say that therefore the median would be, let's just write it down, 30 centimeters. Now, I think we've got to bear in mind actually that this is an estimate, and the reason is we don't actually know what our numbers are anymore. We so we've kind of thrown away the original set of numbers. We don't know where they are. They're in the bin maybe, or they're in a drawer somewhere. So we don't actually know how each of these 120 are spread amongst here and so on. So what we're coming up with here are estimates. So that would be about 30 centimeters. And into quartile range. So the median, well, the median is we also call it the 50th percentile. We can call it the 50th percentile. It's halfway through this set of 400 numbers. And equally, we can come up with any other percentiles. You know, if we want to go 20% the way through the numbers, which would be 20% of 400, then we'll be looking for the 80th. You know, or whichever percentage we want. But one of the things we tend to be interested in are the quartiles. So that'll be the 25th percentile. So the 25th the way through are 400, in other words, 100. And the 75th percentile. And we call these the lower and the upper quartiles. So we would be looking at well, the lower quartile out of 400, that would be 100. So if we sort of look at that across the graph and down, that's going to give us a figure of something like, that looks like about 17 centimeters, doesn't it? So 17 centimeters, let's just write that down. And then the 75th percentile, well, 75% out of 400, that'd be 300. So that would be this point here. And if we go along and then down, that's going to get us to what looks like 37 centimeters. So, and we could describe the range as that, but normally it's the actual width of that gap, which would be in this case therefore 20 centimeters. Okay, so it gives us an idea of the spread of the kind of the middle bulk of the plants, which is actually quite a useful thing in most situations. So we're often describing data by the median and the interquartile range. So where it's centered and how much it's spread out. Okay, so that is that. It also asks us here for the 80th percentile. Well, the 80th percentile would be 80% of 400, that's 320. So again, this corresponds to one of our blocks. We can just kind of read that across and down. That's going to give us 40 centimeters. And then the last bit is it says the number of plants with a height greater than 60 centimeters. Again, it corresponds to one of our blocks, as it turns out. So if we do the reverse thing, 60 centimeters will take us up to here. That's 361. So all this number here are plants that are going to have a height of greater than 60 centimeters. So if that's 361, I would say that's 19 plants. Again, stress these are estimates. We could find these things out from the data. We could plot our way through the 400 readings and actually, well, for this last one, we could actually count the number of plants, couldn't we, with height greater than 60 centimeters. But, you know, that data isn't available to us. So we're going to actually deduce it on an estimate basis from our graph. Okay, so that is a cumulative frequency graph, and it helps us to estimate medians and quartile ranges, and something like this last question here, number of plants with a height greater than 60 centimeters. Okay, so anyway, this particular question goes on, and it kind of more or less sort of says, actually, that wasn't the data from which it came. The data was actually this. Okay, so forget about that now. And we've got different frequency groupings here, and they're each with its own frequency. Now, this part of the question looks at a different presentation of the data in what we call a frequency density diagram. Now, the idea behind a frequency density diagram, if we can look like this, is that if we're looking at this class interval here, then the frequency is related to the area that is proportional to it. And so if we look at this, now I've gone forward and drawn the whole thing. So we can look at it. This bar here is higher, isn't it? It's actually higher than this one. But it's probably not too difficult to see that actually the area between 20 and 30 is actually smaller than the area between 0 and 20. So that kind of gives you a bit of an idea of what we're talking about here. So the key thing here is all right. We're looking at the area, but what actually is the relationship, and how do we, in this particular case, how do we actually complete this diagram? They've given us the first first block, but we need to draw the subsequent ones. That is what the question is asking. Complete the histogram to show this information. Okay, so I have said that the width times the height, the area in other words, is proportional to the frequency. So if we apply our proportionality constant, if you've done direct and inverse proportion, you'll understand that better. But even so, you can probably see that this is what we're talking about. It's some constant. We usually use K, or we often use K to denote that. So this is our little formula here: width times height equals the constant times the frequency. Now, if we look at that for the one that we know, width is 20, the height is 3. That's going to be equal to some constant times 120. Well, that gives us that the constant K is equal to half. Now we can use this for the other class intervals. Now that we know that, we can apply this K into this little formula. So for the second class interval, the width is 20. You can see from there it's 20. So we're just looking at this block here. And that is going to be equal to well, let's just work here for the first one. So 20 times 3 equals k times 20. So that kind of just verifies the the first one. Then the second one is the width of 10 times the height h, which we're trying to find, equals our constant of proportionality, k times et, which is the frequency. So we're just applying this little formula here, now that we know k, to the second class interval. All right, so that's very easy. That just gives us an h equals 4. So we know the height of this block is now 4. Okay, and so we can draw that in, and then we repeat the process for the third, which is also with 10. That's a half times 124. So again, just applying our little formula gives us a height of 6.2, brings it up here. And then the last class interval is quite wide. It's 40 wide. It goes from 40 up to 80. It's got 76 in it. So we can basically just apply our formula again. That gives us a height of 0.95, which we've drawn in there. Okay, so I think if we were to actually examine these areas here, we would see that this area here is, in comparison to the total area underneath our frequency polygon, it would be 120 400ths. This one would be 80 400ths. This would be 124 400ths, and this 76 400ths. Okay, so that really completes that histogram. Now, these diagrams are actually quite useful when, you know, in sort of quite a number of other applications. And if we can imagine joining all these things up, it's going to give us a little bit of an idea of how the data is spread. Anyway, we don't need to do any more than that just at the moment. So that really is just an exercise in how we draw these frequency density diagrams. Okay, so I think that's probably as much as I want to say at this point. So hopefully you've found that useful. And there'll be some more worked examples on this for you to have a look at. But hopefully you found that useful, and I'll see you next time.